Next up, we have Mr. Jim Little. And Mr. Little is a native of Oregonian. He's a native Oregonian and native Portlander. He's also a graduate of Cleveland High School and Linfield College. He studied meteorology at the University of Texas, the University of Utah, and Mississippi State University. Jim also has held various positions on the Executive Council of the Oregon Chapter of the American Meteorological Society over the years. He began his meteorological career in 1971, 2 years before I was born, actually, just in case you wonder. As a second lieutenant in the United States Air Force, Jim's military duty stations included Austin, Texas, Tacoma, Washington, Guam, and Omaha, Nebraska. Jim has been a television meteorologist in Idaho, Utah, California, and here in Portland. I think it's interesting to note, I was his youngest weather spotter when I was 12 years old from Vancouver. I pestered this guy before the internet was even available. That's right. And here we are 30 years later. Still geeks, definitely. Jim provides specialized forecasts for the Oregon Department of Forestry and the Oregon Department of Agriculture and Department of Environmental Quality, as well as private clients. Ladies and gentlemen, please welcome Mr. Jim Little.
Thanks, Steve. How many of you have been to Saturday Market in Portland? You know that guy who sits there with his back to the wall, and he's got his guitar case open, and he strums the guitar and sings songs, and you throw quarters and dollars in there? I feel kind of like that guy pulled up on stage to follow Paul McCartney. I have no musical talents whatsoever. I do have a musical reference if I remember to throw it in here, see if anybody gets it. Pete Parsons is not here today, and Pete and I, many of you know, Pete and I work together. Our desks are adjacent to each other, and he wanted to say hi to everybody. I'm sorry he couldn't be here today. His forecast for the next 3 months is posted online, and he does that every month. He posts a forecast for the next 3 months, and it's on the Oregon Department of Agriculture site, actually, because he used to work for Ag, and Ag hosts his forecast. So if you want to check out Pete's forecast, are you going to show it here or not? I don't know.
Well, we took away the tease.
Time, I suppose.
I got Pete's forecast at 6 o'clock last night. He emailed it to me. As soon as Jim's done, it's only 12 slides long. We'll fly through it real fast.
But Pete and I were talking, and we decided no winter meeting would be complete without this slide. So he graciously consented to allow me to show it this year. And I got a hold of this, and I did some fairly sophisticated digital processing of the picture. I was actually able to see who that was. So Pete's secret is out.
That's great.
Very sophisticated digital process. The title of my talk, Seasonal Forecast Using Objectively Chosen Analog Years. That sounds pretty technical, so maybe I'll make up for George. I got some geeks. I'm going to talk about the technique I use, the verification last year of the technique, analogs for the upcoming winters, which years I picked as analogs, and then, of course, the forecast. This is the winter forecast meeting. So what is analog seasonal forecasting? At its heart, it's really not all that sophisticated. What you do is you look at this year so far, what's happened this year, and you look for past years that are similar to this year. And then you use what subsequently happened in those past years as a forecast for what will happen this year. You combine those things in different ways, and there are some subtleties to this, but at its heart, it's actually quite straightforward. The trick is to find out what is a similar year to this year. What past years were similar to this year? How do you decide that? Well, one way to do that is using climate indices. And this is a non-comprehensive list of some of the ways that we've tried to shoehorn a complex system into one number to describe it. And that's not unique to climate. We do that, we have Category 5 hurricanes, we have EF4 tornadoes. And it's not unique even to meteorology or even to science. We have red states and blue states. And that's just something we do is we try and categorize things. It's something that I think helps humans organize the information. But the beauty of the climate indices is they are numbers, and then it's easy to compare those numbers. So that's what I do. Here is an example of what you do. You look at a climate indice, and you see what's happened, or which years match that climate index in the past, and then you see what did those climate indices do in the future. But you don't just look at the indices, you also look at the sensible weather. Was it warm or cool? Was it wet or dry? And by the way, pay no attention to these numbers. This is old data. This is just a conceptual graph now. But that's the process to come up with an analog year. Figure out which one of these past years matches this year, and then what happened in those subsequent years. What I did, I'm lazy, and I automated the process. I don't want to sit around and think about it. Pete does. He labors over these things, and he's working on his forecast all last week. And I hear him muttering over at his desk, you know, I got nothing. I'm just going to put up a slide that says I got nothing. So I may have nothing as well, but I didn't work nearly as hard as Pete. What I do is I compare each previous year to this year for numerous climatological indices. I compute a goodness of fit, how well did the curves match for the previous years, and then I sort those so that the best fits bubble up to the top of the list, and I save the results and do that for multiple indices. And that's how I come up with my analog years. I find a consensus among those lists and try and decide, well, actually it's the top 6 years. Really no consensus at all. But it's all done with programming and big massive computers. Actually not big massive computers. Here's how it was done. Here's what I came up with last year. This is what the system came up with last year. And the analog years you see there. And here was the forecast that I presented, or that I showed at this meeting last year. And I do by climate division, and I've come up with categories such that the climatological probability of above normal, near normal, or below normal is 1/3. So you've got a 1/3 chance if you just picked a random year of being in any one of those categories. So you would expect that you just throwing a dart, you'd get about 4 of them right. Here's what was observed. Son of a gun, I got 4 of them right. So I didn't lose to climatology. But I didn't win. There were 4 hits, 6 1-category errors, and 2 2-category errors out of those 6 forecasts. 6 months of temperature and precipitation. So clearly the method needs work. But a professor of mine way back in the early days at the University of Texas said the way to learn forecast is to forecast. And so I'm back here trying it again. And that's true. I mean, I think anybody who has a degree in meteorology will tell you that's pretty much how they started out. Just start forecasting. Figure out what works and what doesn't. So moving on to next winter. A little bit of snow, a lot of snow, wet, dry, who knows. These are the indices that I used, and I actually added some indices. And this is more of a mechanical, this is where a lot of the work takes place, is getting these indices in a format, a computer program that I can parse. So these are the indices that I used. If you look at those closely, you can see most of those are El Nino, La Nina, ENSO-centric. So this is heavily weighted on El Nino. Kyle, I have the sun cycle information in there. It doesn't seem to add much to this method. That's not to say it's a bad method or that that's not a good indicator, but I haven't found it to do anything for me. These are the analog years I came up with this year, and I don't think I recognize any of yours, George, is in there. so we'll see. We'll see. So I take the analog years and then I come up with composites of various meteorological parameters and try and discern what the weather's going to be. So my analog years: 2009, 1963, 2001, 1986, 1996, and 1968. These are the 500 millibar heights averaged over the month over those 8 years, averaged for those 8 years. And how about anomalies? Actually, we're fairly close to average in the Pacific Northwest, below average 500 millibar heights down here, above average 500 millibar heights to the north. I think that indicates kind of weak flow, doesn't it? Not very strong jet stream for December. Here's 850 millibar temperature anomaly. Very cold over western Canada and back down into the plains here. But we're kind kind of in that in-between area, so not much there. Here are the climate division averages, and again, there's a pattern there. There's definitely a pattern for cool in the Midwest and warm back up in the Northeast. But out here in the West, I don't know, there's not much there. It's hard to know without really going into great detail and doing more work than I want to do, whether the areas like on the West Coast here, is that because they all were in the average category, or were they scattered all over and they just averaged each other out? Here's the precipitation anomalies for December. Again, not a whole lot there. Above average west of the Cascades, but no strong patterns there, so I don't know. January, the ridge moves a little bit to the east. Here's the anomaly pattern. So lower than average heights at 500 millibars off Vancouver Island. And here's the 850 temperature anomalies. And that looks pretty cool. So you would expect pretty cool surface temperatures, right? That's not what came up when I did this. So what does that mean? Warm surface temperatures and cold aloft? Unstable, pretty active weather. If we have westerly flow, that means probably a lot of rain west of the Cascades, and that shows up. And I think there is maybe a pattern there. It shows up in Washington and Oregon and down into California. West of the crest of the mountains, it's wet. So we'll see. Looking ahead to February, again, the ridge over the western U.S., slight positive anomaly. Very cold in West Texas, and I can hear Judy Collins singing about blue northers just looking at that map. There's my musical reference.
Wow.
Who knows what I'm talking about?
Wow.
That's the problem with getting old. I get these musical references, and everybody's too young to remember that. Someday soon. There you go. Google it. Look at it on YouTube. It's a good song. Warm over the upper Midwest, cool along the southern tier states, and not a lot for us here for February in terms of temperature. But look at this. Very dry, especially west of the Cascades, and that's different than what other people have said. So I guess that's where we're going to duke it out. It's February precipitation this year. March, I'll come back and talk a little more about February precipitation as well. March, a fairly zonal flow, not a whole lot going on there, and not much of an anomaly over the Pacific Northwest, but very cold temperatures over Canada and again back down into the Midwest for March, and that shows up. It's repeated in the pattern of the climate division composites. And really not a whole lot showing up here precipitation-wise. So again, I don't know if that means everything was different and the analogs don't have anything in common and they cancel each other out, or if all the analogs were in that average category. Also did this for April and May. I don't want to bore you with the details, but I do want to say that all of the graphs that I show here get produced for every month for the next 6 months, and they're available at this URL. And I'll leave that up there for a couple of weeks, and you can look at these yourself and see if you can come up with anything, and I'll show that URL again. Looking at Portland and the Willamette Valley is Climate Division 2 in Oregon, and this is the forecast. And what I do is I look at above or below average or above or below median for a 2-category forecast, and then a 3-category forecast above, near, and below. And these are set up such that you have a 1/3 chance climatologically of being in each of those categories. So for example here, the above and below showed 50-50 for temperature and 50-50 for precip. On the 3-category though, 4 of the 6 years were in the middle category, in the near category, and half of the years were in the below category. So the objective forecasting comes out near and below. That's for Climate Division 2. Here are those years plotted, temperature, precip, kind of a meteogram for the month for all of those analog years, and it's hard to see a pattern there. Nothing leaps out at you in this display. Here's something else that I do, and this is the blue line here is the average high temperature, average high and average low temperature from 1950 through 2010. And then the red line is the average daily temperature for the 6 analog years. And this is December. Don't see much here except a little cooler than average maybe, first part of the month, fairly close to average. There is a cool spike down here, but if you look back at those Portland meteograms, it's all from 1968. Not a whole lot there. So I got nothing. This is for January. Same thing. Came out near average for temperatures, above average for precipitation, but no strong signal. And certainly looking at this, nothing leaps out at me. This is not a particularly useful tool, at least not with this data on it. So here we go with this. This shows maybe slightly warmer than average the first part of the month, slightly cooler than average the second part of the month. But remember, I thought it was going to be kind of an active month, so this, again, I would say this is our best chance of snow, but it's our best chance of snow climatologically sometime in January. Although low-level snow with warmer than average temperatures, or I don't know. I don't see anything here. This is probably good for the Cascades because it's going to be cold enough for snow up there. For February, this was the startling thing. Maybe not startling, but all 6 of the analog years were below average, and 5 out of the 6 were in the below average in the 3-category scheme. So it came out February, a dry month for me. Here are the 6 analog years plotted as bar graphs. The median precipitation for climate division 2 is the gray line there. And to be in that near category, you have to be in that range there between the kind of yellowish and blue line. And only one station, or 1 year rather, made it into that category, and only just barely. The others were all well below that. So those analogs indicate a dry February, below average precipitation. Also, how about for the rest of the state? These are the climate divisions precipitation composites for those years. And all of the divisions west of the Cascades and several east side are dry, and note particularly the northern Cascades are particularly dry. So if you're taking a ski vacation in February, maybe that's the one you go somewhere else. So, Portland temperatures for February. The highs, we show a kind of a warm spell there toward the middle part of the month, but really nothing big. There's a spike down there toward the end of the month. Maybe that's our Arctic outbreak. Maybe in spite of a dry February, we get our big snow at the end of February. For March, I got nothing. Near average temperatures. There are the analogs, or the plots for Portland for each of those years. Not a whole lot there. And again, maybe a little cooler than average the first part of the month, maybe a little warmer than average the latter part of the month, but not a whole lot showing up. So, in summary, this is the forecast for the Willamette Valley. How about the Cascades? And I did this last year, and used the same scheme, and this is the forecast for the Cascades. Temperatures near average until April. Precipitation near above, below above, below. So, I don't know, March and April above average, maybe some good spring skiing in the Cascades. I did this last year as well. I don't have data for the ski areas, but I do have it for government camp. And this is snow depths through that Christmas week. And 4 out of the 6 years, pretty good. 2 of the 6 years, kind of marginal. Probably no skiing at Ski Bowl, but the higher ski resorts may be okay. I'm not sure how different this is from climatology, so, but 4 out of the 6 years look good for the Christmas vacation scheme. That's it. There's a summary again of the Willamette Valley forecast. I can be reached at those email addresses, and the graphics that I showed here and more are available at that URL. And I'll leave that there for several weeks if you peruse it. Thanks, and I guess we'll do questions later.
Actually, since Jim works with Pete Parsons, everybody, I've seen Pete's forecast. I think you're going to want to see it real quick. What do you think? You think it'd be appropriate for me to do it, or for Jim to put up Pete's? You see Parsons?
Jim. Jim.
There you go.
Where is it?
It should be Parsons.
Well, he's already used
I
it.
took out the
Yeah,
PWO.
right.
There you go.
Well, Pete does this, as I say, Pete does this every month, and he puts a lot of work into it, far more than I would. But this is his thing, and Pete's really into this, and we discuss it. I mean, I don't have any significant input into this, you know, but he does bounce ideas off of me. I mean, it's all his. I feel honored to be even a small part of it. So I haven't seen this yet. I don't know what he came up with. Obviously, I've got nothing to not make it under the slides, but there you go. So he's going along with what CPC or whoever said about El Nino. And here's the tropical Pacific Ocean temperatures. Let's get to the forecast. Here were his analog years: 2008, 2000, and 1950. Any of those match yours, George? I don't think so. No? Yeah, so, okay. So everybody's got something different this year. There's how his matched the O and I. And this is the IRC CPC graph that I think Clinton showed. And so neutral conditions, most likely through mid-2003. So here are the Oregon climate zones, and here's what Pete came up with. Let's look at this. He's got temperatures below average for December, most areas, and precip near average, except a little above average in southwest Oregon. Stormy periods likely, cooler than normal with near to above normal precipitation, increased chance of Arctic outbreaks late in the month, all right? Diverse weather during the analog years, some mild and stormy, and others with significant cold episodes, lowers forecast confidence. That's what I was talking about. You know, they average each other out. For January, temperatures, he's got above average precipitation. He's got it really wet along the coast. ENSO neutral conditions favor stormy and mild periods alternating with cold and dry stretches, often with Arctic outbreaks and valley snow. Overall temperatures will depend on severity of any cold snaps. Diverse weather during the analog years lowers forecast confidence. That's code for I got nothing. February 2013. Temperatures, it looks like a mix. Some above and some below, and some in that middle ground. And precipitation for February, he's got dry conditions west of the Cascades and in northeast Oregon. Okay. So there's, this is for the 3-month period, averaging them all out over the 3 months. And kind of a mixture in temperatures, and it looks like kind of a mixture in precipitation there. So ENSO neutral conditions favor Arctic intrusions and valley snow events, mainly from mid-December through January. And that's, a lot of that's based on work that George did several years ago. I mean, I don't claim credit for that. He doesn't claim credit for that. That's the George Taylor syndrome, right? Okay. There are no excellent analog matches for this winter. Looking back over the past 100 plus years, it is rare to have back-to-back La Nina winters, the past two followed by an ENSO neutral conditions. This year is also unique due to the recent decay of what appeared to be a developing El Nino episode. ENSO neutral winters tend to produce stormy and mild periods, alternating with cool, dry periods, often Arctic outbreaks. The transitions can bring valley snow and ice. The favored ENSO neutral period for Arctic outbreaks and valley snow events is from mid-December through January. Okay, and this is posted on the web, and this is a great resource for people. He only goes 3 months into the future. He doesn't do the August covering the entire winter thing like George, but it's there every month, and he does a lot of work on it, and he'd be happy to have you send him some feedback. Okay.
All right. Thank you, Pete, vicariously through Jim.